Financial statement analysis involves valuing firms. The purpose of this video is to review time value of money concepts with a focus on present value. The value of any asset is equal to the present value of its future cash flows. Determining the present value is critical to this course because the valuation models we use this semester apply present value techniques to various measures of firm performance or ways to measure the value of a firm. This video is going to show you how to find the future value and present value, calculate the present value of a cash flow stream, and value a stock using the discounted dividend model for a constant growth stock. To start with, I'm going to start out the same way your Financial Management Finance 215 class started out. And let's say you invest $100 for 3 years. You leave it invested for 3 years at an interest rate of 5%. Let's see what that will look like by the time we take out our money at the end of year 3. So we put in 100 here. We want to know what is the value at the end of year 1, the value at the end of year 2, and the value at the end of year 3. As time goes on, this asset is going to earn 5% on top of the initial 100. So at the end of year 1, you'll have 105. That 105 is going to earn interest of 5%. And so we're going to earn interest on the interest, or see the impact of compounding here. That $110.25 will be invested at 5%. So at the end of year 3, our investment will be worth $115.76. Now, what if we wanted to go backwards? What if we want to solve for the present value of $115.76 to be received in 3 years' time? So we assume that we know this $115.76 and we're trying to figure out what it would be at time 0. Well, we do the reverse, as we can see here. The $115.76, we need to divide that by 1.05. And we get $110.25. As we see here, we take the $110.25, divide that by 1.05, and we get the 105. Let's discount the 105 back 1 year, divide by 1.05, and clearly we would see we get back to 100. So our formula here for present value is equal to the future value divided by 1 plus the interest rate to the exponent of the number of years that we are investing. In this case, that present value is equal to the future value of $115.76 divided by 1.05 to the third, and this works out to be 100, just as we expected. All right, how about finding the present value of some cash flow stream? The last example, we looked at making one cash initial investment. Oops, sorry about that. Now we are going to look at the present value of a cash flow stream. And here we're going to see an example that fits the characteristics of a bond. Let's say we have a 5-year bond. We're here in time 0. This is the present value. We have time 1, 2, 3. Let's fix the spacing here a bit. Time 5. And let's say this bond pays us $100 coupon payment in each of the periods, and then at the end of the 5th year we get back our $1,000 face value or principal of the note. So we are receiving at the end of year 5, we are going to receive $1,100. Our question is, what is this bond worth today? What is the present value of these future cash flows? Well, we just discount each one of these cash payments or cash receipts that we're going to have in the future. Let's say our interest rate is 12%. This would either be the market rate, or we can consider this a discount rate of 12%. So we're going to take $100 back, discount it by 1.12. We're going to get $89.29. We need to discount $100 to be received in 2 years. We need to discount that back 2 years. So 100 divided by 1.12 squared for the 2-year period. And this is going to get us 79.72. Year 3. What's the value of this cash payment to be received at the end of year 3? 100 divided by 1.12 cubed. 71.18. Year 4. This is where you might want to turn your settings of this video up to watch this perhaps in a faster speed. And in year 5, we take our full $1,100, the face value, the principal or face value, plus the last interest payment, and discount that back for the 5-year period. We get $624.17. This is the value of each one of our payments over the period. We're going to add all of these cash flows up here and get a total of $927.90. This is the present value of this cash flow stream. Or we would say, if this is a bond, the present value of the bonds. If the example above offered uneven payments, let's say this was 100, 300, 200, 600, 400, why might this happen? Let's say a manager is considering investing in a project with some uneven cash flows at the end of each year, and then at the end of the period, the project is going to be discontinued. We would do the same process, just discount each and every one of those cash flows back to the present value to obtain the present value of that project. You can see an example of this in Chapter 3 in the 5th edition. This is shown on pages 89 through 90 in a section titled Present Value of a Project. What if an asset pays cash flows indefinitely? We would call that a perpetuity, and the present value of a perpetuity is equal to the amount of that payment that we're going to receive divided by the interest rate. So let's say we have a preferred stock that pays a constant dividend of $2.50 per year indefinitely. Let's say your discount rate or your required return is 10%. The price of this stock, this perpetuity, is equal to $2.50 divided by that interest rate. You'd be willing to pay $25 for this perpetuity. Now let's move on to valuing stocks. The discounted dividend model. You learned about this in Finance 215, Financial Management. The price of the stock depends on the dividends that are received during the holding period and the price that's received when the stock is sold. So we could say the estimated price of the stock at time 0 today is equal to the present value of the expected future dividends And so now what we do is we look at a model very similar to the bond, but instead of our payments being those interest or coupon payments, we look at our dividend payment. So we would take our first dividend, discount it by 1 plus the interest rate, discount for 1 period, plus the discount we expect to get in the second year. We're going to discount that back. And so on if we assume that the company continues indefinitely. This would go all the way out into infinity, and we would discount out to infinity. So we can see here from time 1 equal to infinity, we're looking at the sum of each dividend discounted by 1 plus the rate, the required return, or the discount rate. And let's look at this applied to a constant growth stock. What is the price of a constant growth stock? Well, here we're taking the model from before, but we're trying to say that there's a pattern to the dividends, to D1, D2, all the way up into infinity. They are going to grow at one specific growth rate, G. So what we do, the price of the stock would be equal to, well, we would think about what was the last price, the last dividend that the stock paid. We would know that. So we would take that last dividend, D0, and we would grow that by multiplying D0, the last dividend, by 1 plus the growth rate. And then we'd have to discount that by dividing by 1 plus that required return. The next dividend, D1, would refer to this dividend here, D1 times 1 plus the growth rate. And now we are going to square it. Actually, if we take D0, then we're going to square the growth rate. Alternatively, we could simply take D1 times 1 plus G, but then we don't want to square it. Divide that by 1 plus the rate. And do this all the way until infinity. This works out to be D0 times 1 plus the growth rate, G, divided by the discount rate, R, minus G. So G is the growth rate. Of course, that involves quite a big assumption on what that constant growth rate is. And R is your required return on the stock given its risk level. So let's say that D0 is $1. The company's most recent dividend was $1. We expect a constant growth rate of 5% and a required return on this stock given its risk level is 12%. So we would start, if we're using this model here, this equation for a constant growth stock, what we would do is say our D0 of $1, multiply that by 1 plus the growth rate, 1.05. Clearly our next dividend is going to be $1.05. Divide that by R minus G, 0.12 minus 0.05. So if we take 1.05 and divide it by 0.07, we get the stock's price of $15 per share. In the next video, I'm going to work out this model for a non-constant growth stock.